This is very exciting.
Thank you very much, Joseph, for the kind introduction. I want to start out with the Colonial Pipeline outage incident, because this has been actually fascinating to watch the reaction to this. In some ways, it's kind of like a Rorschach test, and you can tell a lot about each individual's mindset based on how they respond or how they actually view this incident. For example, not surprisingly, if you are a product vendor or a service vendor offering security services or products, we are seeing these people say, if you would have used our product or service, this would not have happened. So this is why you need to use our product or service. And that message is actually getting out there. I was surprised. I actually have heard senators, U.S. senators, say that the biggest problem is people were not using two-factor authentication for remote access, which is just fascinating. And they're not wrong. So hopefully that's something that will come from this. On the flip side, if you look at the government's reaction to this, their mindset is saying, well, this shows private industry is not capable of securing these critical infrastructure systems. We need regulation. We need rules. We need to get more involved. We need to help them. When you kind of look at this and you say, well, what is the job that the U.S. government's doing in securing their own systems? I'm not sure how much help that'll be, but it's coming because that's their mindset, and we'll have to see how that goes. And then you have people that look at it from the legal perspective, and they're looking at the ransomware element of this, and they're saying, wait a minute, we should not be paying ransomware. That's the whole problem. So it's been fun to watch this. I will tell you, though, that it actually, the way I view this reflects my mindset, and it's a little bit different because I've been just really focusing in the last year or so on the consequence side of the risk equation and the impact of these attacks. Because if you really look at the Colonial Pipeline, to me, I think it should lead you as a manufacturer to ask this one question. Can I manufacture and deliver my products to my customers if my IT network or my enterprise network, whatever you call it, is compromised? Because that's what actually happened here. To the best of our knowledge so far, at least in the public information, this attack never got to the OT network. It strictly stayed on the IT network, and this caused them to shut down their capabilities to deliver products through their pipeline. So you should look at yourself and you say, well, wait a minute, what if my enterprise network was compromised? Could I meet my mission of manufacturing and delivering products to my customers? That's, in my mind, the question you should be asking. Because if we think about it, are we ever going to be so confident in our sets of security controls that we are going to be able to say, we can be sure that our enterprise network is not going to be compromised? In fact, if you talk to most security experts, they actually say you should assume your network is compromised. So that would make this question even more important. Kind of a secondary question and related question to this is, what is my recovery time objective? If I assume my network could be compromised, how long is it before I can get back up and running and delivering my products or services to my customers? In this case, the Colonial Pipeline was actually an interesting case because they had a 7-day commitment for any cause of outage to the pipeline to get the pipeline back up and running again. And in fact, they got it up and running in 6 days. So in a sense, this was almost a messaging problem on them. Well, one of two things. Either they didn't make it clear, they weren't confident that they could actually recover in 7 days. Because if they were, they could have said, we have this policy that we have the ability to recover within 7 days, regardless of the cause, whether it be a cyber incident or a labor issue or a weather issue or anything else. That's our commitment, and we are going to meet it. In which case, that would have brought down a lot of the panic, I think. Or perhaps they weren't confident that they could meet that. So one of the first things you need to do, if you haven't done already related to this, is you need to not only decide what would happen if my enterprise network was hit, but what is my recovery time objective? And you want to make sure the right people are making those decisions, and then be confident you can achieve it. And there's no secret sauce in being confident if you can achieve it. You just have to actually do the test. If this bad things happen, could we actually get back up and running in the time that we say? Now, I'm going to talk a lot about the risk equation here. This is the simplest version I've seen. Risk equals consequence times likelihood. Both sides of this risk equation are very important. It is extremely important that you understand your organization's risk management. I actually wrote an article on this that came out today, where someone was making a huge deal that cyber incidents, specifically ransomware, were causing hospitals to lose $133,000 a year. Now, they would rather not lose that potential revenue, but $133,000 loss per year would actually be an acceptable outcome to a large hospital with $2 billion to $4 billion in revenue. I mean, that's nothing. They lose 6% of all their revenue to unpaid bills. So $133,000 is not going to be a big deal. What we need to do in the OT community is we need to realize we're not some special little flower, that we need to work within the risk management system that exists for our organizations, for our companies. And a lot of you probably have seen these, or hopefully you have, where your company will have a risk matrix with likelihoods on one axis and consequences on the other. And we need to understand where potential cyber incidents related to OT fall in that risk management matrix. Now, I see two problems very frequently in the operations world when it comes to this risk matrix. The first one is trying not to use it. That's actually, I guess, one that I don't even include. But when they're looking at this, I guess the first problem would be engineers, technicians, people in operations accepting risk when they have no authority to accept that risk. So, for example, they might say, this really high consequence event could happen if the bad guys get into here and do these things. But in their own minds, they say to fix that, it is going to cost us this amount of money, and there's no way the company is going to approve that amount of money. If you're doing that, you're making what I call a career limiting decision. Because if this bad thing happens and you didn't ask for that money, then it's going to be your fault. And in fact, a lot of people today in the OT world or in the operations world are accepting risks that they know about that they don't have the authority to accept. So you really want to make sure if you identify a risk that you bring it up to the right level where they can make the decision whether to address the risk, mitigate the risk, or accept the risk. The other issue that we see a lot is people in operations sometimes overestimate what this event means to a company. They might think, oh, this is the end of the world, when to the company, like that hospital example I gave, $133,000 to a hospital, not a lot of attention is going to be given to that. And I think a really good example that I've run into a few times has to do with power generation. So if a power plant gets hit by a cyber attack and is unable, let's say, to generate power for a month, is that a high consequence event? Now, if you're in that plant, you would probably say that is a high consequence event. That can never happen. That would be a catastrophe. That would be a huge issue to the company. We must spend any amount of money to prevent that from happening. And that may or may not be true. For example, I live in Maui, and in Maui, we actually only have one large power plant, and we have no transmission lines to the island. We have a couple of smaller power plants, but if that one power plant was out for a month, most of the island would not have electricity for a month. That is a high consequence event. But now I've worked with utilities on the eastern half of the United States, and they every day are making the decision on whether to run a power plant or to buy the power from somewhere else, because there's this grid that you can buy and sell power on. So in their case, if they were to lose a power plant, They would still be able to deliver power to their customers. And the financial impact would not be the loss of revenue. It would be the delta between the cost it would have cost them to generate the power themselves at that plant if it was running, and the cost to buy the power. I've run into situations where that cost, even for a multi-month outage, did not even make the moderate risk level. So the people in the plants were saying, this is a catastrophic event. We must stop this at all costs. When in fact, from a company perspective, it wasn't that big of a deal. Now, if, for example, this cyber attack was able to take out the turbines and otherwise destroy the physical part of the plant, that might have raised the consequence. The financial impact might have been much higher. But you want to look at this. You want to look at the consequence of the event and where does that fit in your own risk matrix. Okay, so let's go back to this equation. Consequence times likelihood. I assume that most of the people on this event, watching this event, are security people. And security people, we focus almost exclusively on likelihood, on reducing the chance that this bad thing can happen by putting additional security controls in place, one after another after another. This makes a lot of sense. And in fact, some of the ones that Fortinet and others put out with perimeter security, some basic monitoring capabilities, they have dramatic risk reduction and do belong early in your risk reduction approach. But after you get through the basics, what we're finding more often than not with a lot of asset owners is that consequence reduction is actually their more efficient risk reduction than putting in additional likelihood or security controls, likelihood reduction or security controls. And when I say efficient risk reduction, what I'm really talking about here is, as an asset owner, where would I get the most risk reduction for the next dollar I spend or hour I spend on it? And once, again, just to say it again, once you have your basic likelihood controls in place, what we're finding more often than not, spending money to put additional control in place, what you're doing is you're moving your, let's say, your likelihood from very, very small to very, very, very small. It's even really hard to quantify that. I mean, I don't know if you've ever had to go in front of the executives and ask for money for a security control, and they ask you, well, first they ask a bad question. Will this mean we'll never be compromised? And of course you can't say no. This reduces the likelihood. But then they're probably going to come up with a secondary question. They're going to say, well, how much? How much does this reduce the likelihood? You need an answer to that question, and you can start to talk about attack paths and things. But let's admit it. It's a fair amount of hand waving. We're not able to give them concrete numbers that say, well, this reduces the likelihood of this attack from 0.7 to 0.45. We just don't have that kind of data. The nice thing about looking at the consequence side of the equation is you get those hard numbers. You can say, if the adversary gets into our system and causes this high consequence event, it will cost us, let's say, $100 million. But if we spend this amount of money, we can reduce the impact of that event from $100 million down to $5,000. Those are things that executives can understand. So that's a kind of a hidden benefit of focusing on the consequence side of the equation. It makes those discussions much easier. But let me give you an example of consequence reduction in the manufacturing space. Now, I'm sure a lot of you realize that is not actually a glass factory. I couldn't find a Creative Commons picture of a glass manufacturing factory. A lot of it is because it's a very sensitive operation. But the key thing about the picture in glass factories is they operate at extremely high heat, actually above 3,000 degrees Fahrenheit. That's the temperature when something re-enters from space, like a space capsule or a meteorite. It's at that temperature. So that makes things very interesting, potentially very dangerous in a glass factory. And as we are working with a glass manufacturer, We looked at their process, and of course the line has some motion to it. There's heat. Of course, it's much more complex than that. But in this case, the heat itself was controlled by a Rockwell Automation, Allen Bradley Control Logics PLC that you see there. As we're looking at various scenarios and what the adversary could do with access to the system, one of the scenarios was they could send a command to the control logic to turn the heat up to its very highest level, and then they could brick the control logics so that the heat could not be lowered. Bricking a PLC or any level 1 device is not terribly difficult to do. Unfortunately, some of my researchers and people in our labs in the past used to do it all too often. One of the things you can do is you can just upload bad firmware. Again, because oftentimes the command to turn up the heat or to upload firmware is unauthenticated. And if you think this is something that just happens in the lab, we actually saw a real-world incident of this in the Ukraine in 2015. That's where the adversaries got on the network. They opened the relays to shut off the power to a significant part of Ukraine, and then they bricked the serial to Ethernet gateways by uploading bad firmware. So this is not just something theoretical. This is something that the adversaries know how to do. Now, in this case, if the heat was turned up to its highest level and then could not be turned down because the control logics was unavailable, what would happen would be the liquid that is going to form glass would get so hot that it would actually melt the line. The production line itself would melt. This is something that they plan for, because this is a real world possibility. So when they build these, they build the whole line over essentially a gigantic pit that they put a floor on top of. So if everything melts down, it melts the floor, it melts into a gigantic pit. When that happens, of course, you lose the production line. In their case, it was going to cost them tens of millions of dollars to rebuild the production line. And you have an outage of, in their case, at 6 months or more. I think those are both numbers on the low end. Now, in reality, they probably would not let that thing happen because that would be extremely dangerous. What actually would probably happen is someone would hit the emergency stop button, the e-stop button, in which case the heat would shut off, but then all that liquid that was being used to form the glass would solidify in the production line, and you'd have the same issue. You would have tens of millions of dollars to rebuild the line, 6 month or more outage. So as they went through this, they said, not surprisingly, that's unacceptable. That is an unacceptable consequence. The likelihood of it happening is non-zero. So we want to do something about it. And this is now what I'm going to talk to you about now is something I've seen over and over again. When this happens, you get a bunch of people in the room, and the first thing we do, we're security people, is we start to say, well, what other controls can we put in place? Can we put a firewall in place? Well, they already had a firewall. So someone said, well, maybe we can put another firewall in place. Someone said, well, maybe we can put an industrial firewall with deep packet inspection in place. We can do application whitelisting. We can have a second control logics. And just over and over and over these things. And they were all, I don't want to say they wouldn't have had any impact, but we had already, this asset owner had already reduced the likelihood of this attack to a very small amount through other good security controls. So yes, it might reduce the likelihood, again, from very, very small to very, very, very small, whatever that means. So not being satisfied with that, because we couldn't tell the asset owner's management, hey, this can't happen, we took a step back and we said, what's the real problem here? The real problem is, if the heat is up at this high level and the control logic is gone, we can't lower the heat to a level that's acceptable. So what if we put a manual control down on the floor that allowed us to lower the heat to a lower level? Now, this manual control wouldn't have the granularity to produce high quality glass, but it would lower the heat to a level that the materials could flow through the line and the line itself would not be destroyed. So instead of having to rebuild a 10 million plus line, we'd have a little bit of scrap material. And instead of having a 6 month outage, we'd have a day, an hour, whatever it took to feel confident that the control logics was back in place. So we're talking about dramatic risk reduction by hitting the consequence side. The cost of this manual control was about $10,000. And the funny thing was, and this happens a lot, there was some engineer in the back of the room who had been kind of quiet, old guy, had been ornery a little bit throughout the whole process. And he says, we had that there, but you told us to take it out when you put the PLC in. And I think what you're going to find is a lot of the things that you had in place before might be effective consequence reductions. Okay, so that's my manufacturer example. I want to give you a more generalized case and something that you should really look at. And this is related to Triton, because one of the biggest consequence reduction issues we see is the safety and protection systems are available oftentimes on the same networks, the same systems as the control capabilities. So this is what we saw in Triton. The control system and the safety system were both accessible from the same network. You probably have heard long presentations on this, but the bad guys tried to basically disable the safety PLC from doing its job. They weren't successful. They kept tripping it and causing the plant to shut down. But the goal was essentially to disable the safety system and then on the control system cause the bad event, and then boom. So one of the key messages when you're looking at consequence reduction is to look at anything that you're relying on for safety or protection and saying, could a cyber attack on my control system actually disable that? Because if that's the case, you have a real problem. You'll see this not only in separate safety systems, but a lot of times we'll see companies, especially in manufacturing, will say, well, what's something really bad that can happen? You'll hear the answer to that. They say, but no, that couldn't happen because we have soft interlocks in our PLCs to prevent that from happening. Well, if the bad guy is on your ICS network, he can reprogram those PLCs. So that's another area where you really want to focus on in consequence reduction. But now let me make this more general. If you are looking at the consequence side of the risk equation, the first thing you have to do is identify your high consequence events. Now, this is not, for example, a server going down, or it's not even ransomware is not the high consequence event. The event is, let's say, unavailability of the network or having the pipeline being shut down or the plant being shut down. That's what you worry about. And you measure these based on the things in your risk matrix. This could be safety, loss of life, financial, customer impact. You see them up there, environmental, reputation. Now in manufacturing, if you've done a process hazards analysis, you've probably already gone through this. But once you identify these high consequence events, again, independent of cyber, but things that cause a large impact, then you have to ask yourself, could a cyber incident or a cyber physical incident cause that attack? If the answer is yes, that's when you have to look at reducing the consequence of that cyber attack. There are some very good methodologies out there now to do this. The cyber PHA, again, if you've done a PHA, this adds cyber to it. And eventually, I think cyber will just be an integral part of every PHA, process hazards analysis. And then INL has their CCE, consequence-driven cyber-informed engineering. Both excellent methodologies, but I think they might scare some people away. Because when you look at the CCE, it takes man years to actually go through that process. And you don't need man years to start working on consequence reduction. It can be done very simple, and that's actually what I would suggest you do at the start. And it is just as basic as those two steps. Identify your high consequence events, and then find a way to reduce the consequence if a cyber attack could cause that high consequence event. And remember, when you're determining if a cyber event could cause it, you want to think worst case. You want to think the bad guy or bad gal is in your control system with administrative rights. What could they do with that? Or you could just imagine your best engineer goes rogue. What could he do with that? And how could you reduce that consequence? So with that, I hope you look at both sides of the risk equation as you're dealing with cyber risk or any risk to your company. And Joseph, I'd be happy to take a question or two if you have some time.
Thank you, Dave. That was fantastic, and I really appreciated your case studies there. Fascinating, really. Now, we have received a lot of questions from our live audience, so I'll go ahead and get a couple of those in while we have some time here. What would you recommend a company do to test their cyber resilience?
Well, I think I don't know if I like the word of cyber resilience. I think you need to test your resilience, your all-cause resilience, and you just need to include cyber in that. So in the case, we just had the best case with Colonial Pipeline. Are you able to meet your RTO? If this really bad thing happens, are you able to meet it? This could be through a variety of things. It could be moving to manual operations. It could be, in my power example, buying power from somewhere else. But you have to assume this bad thing happens, and then you have to go through the scenarios to see if you could meet it. I think sometimes people, especially in the operations worlds, really leverage redundancy. I would caution people that redundancy doesn't provide as much resiliency against cyber attacks as it does against almost anything else, because oftentimes the cyber attack that would take out your primary system will also take out your backup system. So just be careful you're not over relying on that. That's the answer we hear oftentimes. We said, well, what if an attacker brings this down? They'll say, oh, we'll just go to our backup system. Well, if the backup system are interconnected to the primary system, then it's probably also compromised.
Boy, does that sound familiar to me. It's something to be wary of for sure. Let me get another question in here. Often, cybersecurity is treated as a cost and not a contributing factor to sustained operations. What recommendations do you have for ICS leaders needing executive endorsement for investment in securing their industrial environment to show value to the business?
Well, I have a little bit, maybe a contrary opinion on this, but it is a cost. And trying to pretend it's not a cost, I think, is a failed effort. I don't think the executives are going to be fooled by saying it's a value. I'd look at it two ways. One is, what I found with executives, if we come up with a credible risk scenario and we provide them with options to address that risk. Remember, always provide options. Executives don't like being told what to do. Provide them with options on how to address that risk. Once they understand the risk and believe the risk, spending money is not a problem. I've actually had, more often than not, once they believe the risk, the other problem, that they want to spend money so fast. They say, we want this solved in 3 months. What do we have to do? And it's just not possible to solve that risk or mitigate that risk in 3 months. So I think if you're having problem getting money due to cost, you have to relook at how you're explaining risk to your executives. But then the second side, and this is maybe closer to what you were asking and saying, is on new systems, the cost isn't such a big deal, because typically when you're putting in a new system, there is some perceived substantial value to putting in that new system. And if you can say, well, this new system is going to have these risks and we need to address them and spend this money, spending that money is not difficult. A real good example I had is a lot of SCADA systems operating in remote areas used to have to buy satellite communications, and satellite was very expensive. They wanted to move to cellular data, which was less than 10% of the cost of the satellites. But it introduced some risks. At that point, by saying, well, yes, this introduced some risk, but we're going to have to spend some money to address those risks, was a very easy sell because they could pay for it very quickly with the savings. So I think you have to admit it's a cost and then either approach it one or two ways. If it's an existing system, you have to prove why that cost is worth spending from a risk management standpoint. And if it's a new system, you want to get in there early and you say, yes, there's tremendous benefits, but just part of the cost of this program is securing it, and this is what it is.
Yeah, that makes a lot of sense to me. We've just got a couple of seconds left here, but I want to get one last question in. How do you quantify the impact reduction scoring when conducting a cyber PHA if one were to consider independent mechanical safeguards? What are your thoughts?
Well, see, that is a tremendous question, because that just shows, and I probably should mention this, but the consequence side of the risk equation involves engineers. Okay, that's why security people like the likelihood side, because we have full control on that side, security controls and such. You get on the consequence side, you get into engineering, and a guy like me shouldn't be answering those questions. What we should be doing is working with the engineers and saying, this is how this thing could happen. And the engineers often come up with the consequence reduction options, and they also come up with those numbers that this person is asking. As a security person, don't try to be guessing that unless you have an engineering degree and expertise.